Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kaakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo
I welcome you for these sessions. So our topic for this afternoon is about the permutation. Okay? So but before we proceed to our main topic, so let us do first this review. So actually I prepared two questions for the review parts. Okay, the first one is 10 runners join a race. In how many possible ways can they be arranged as first, second, and third placers? Okay, 10 runners join a race. In how many ways or in how many possible ways they be arranged as first, second, and third placer? Actually, class, you can answer it by way of permutation or fundamental counting principle. Okay, to answer this, we have 10 times 9 times 8 equals 720. Okay, for the second question, we have there are 7 elected members of the board of directors. In how many ways can a president, a vice president, a secretary, and a treasurer be selected from the board? Okay, by way of fundamental counting principle also, we can solve this type of problem. Okay, so we have 7 times 6 times 5 times 4, and we have 840 as our answer. So to further elaborate these two question class, on the third slides, I will discuss it using the permutation. Okay, so let us move on to the main topic, which is the permutation. Okay, the permutation, it refers to the different possible arrangement or orders of a set of objects. Okay, here are different types of writing in permutation. We have the permutation of n, taken n object, taken r at a time, or this one, we have p times the quantity n in r. Then we have also p times n over r. So these are the different types of permutation in writing. But we are decided to use the permutation of n object taken r at a time as part of our discussion. Okay, equals n factorial all over n quantity n minus r factorial. Okay, so please remember this formula, because along the way of our discussion, you will encounter this formula. But there is a condition where n is greater than or equal to r. Okay, so let us try to use this formula for the next question. Okay, so as what I promised you a while back, that I will be giving you details information about what we have, what the problems in first slide. Okay, so there are 10 runners to join a race, and in how many possible ways can they be arranged as first, second, and third placers? Actually, class, we can use this one as a permutation formula. Okay? To do this, you need to identify first what is the value of n as well as the value of r. So from the given, we have n equals 10, and then we have also r equals 3. Sir, where did you get the n? Actually, class, this one is the 10 runners, and our R here is the first and second, third placers. Okay? So using the formula that I mentioned a while ago, so you need to substitute the value of n as well as the value of r. Okay? By doing so, we have 10 as we have n as value of 10, and then we have r as the value of 3. Okay? Using the formula of permutation, we have 10 factorial all over quantity 10 minus 3 factorial. Okay? To simplify, we have 10 times 9 times 8 times 7. Sir, why did you stop at 7 factorial? Because class, our denominator here is 7. So where I did get this 7. So 10 minus 3 is 7. Therefore, we need to copy the sign, which is the factorial in symbol. So uh, I stopped 7 factorial because our denominator is 7 also. So therefore, we need to cancel it or eliminate the 7 factorial, okay, and then the 7 factorial for the denominator, and then we have the remaining numbers are 10, 9, and 8, okay? So to get the final product or answer for this is 720 because 10 times 9 is 90 times 8 is 720. So see, it is very easy for you or for us class to uh, get the final solution using the permutation formula. Okay? So again, there are 720 possible ways. Okay? For question number 2, so there are 7 elected members of the board of directors. In how many ways can a president, a vice president, a secretary, and a treasurer be selected from the board? Okay? So in this type of problem also, you can use the permutation formula. Okay? So in order for you to get and as well as value of R. Just like what we did ago. Okay, so our N here is 7 because we have 7 members of the board, and then we have R equals to 4 because the president, vice president, secretary, and treasurer. Okay, so by doing so again, you need to substitute the given value of N as well as R. So we have permutation of 7 objects taken 3 at a time equals 7 factorial all over quantity 7 minus 4 factorial. Okay, to simplify this, we need to copy the 7 factorial, and then 7 minus 4 factorial is 3 factorial. Okay, so again, we need to eliminate the 3 factorial because our denominator here, this one is 3 factorial also. So we need to cancel the 3 factorial as well as the 3 factorial. So we have the remaining numbers here. We have 7, 6, 5, 4. Then we need to multiply it in order for you to get or arrive the final solution. So 7 times 6 times 5 times 4 equals 840. Okay, 840 possible ways. Okay, that the president, vice president, secretary, and treasurer selected from the board of directors. Okay, now, in this type of question, in number 3, we have in how many ways can 5 people arrange themselves in a row for picture taking? Okay, as you can see, we have 5 people and then they have the freedom to arrange themselves, okay, for picture taking. Okay, so again, you need to identify the value of n as well as the value of r. So our n here is equal 5 and r equal 5. Okay, therefore, our permutation of 5 objects taken r at a time equals 5 factorial all over 0 factorial. Okay? So, sir, where did you get the 0 factorial? Okay, class, because 5 minus 5 is 0, therefore you need to copy the factorial. So, therefore, 0 factorial our denominator here. And then, 0 factorial class, always remember this when we say 0 factorial is equals or equal to 1. Ano, equals to 1. Okay? So, to simplify again, our remaining here is 5 factorial. So, the final answer is 120 possible ways. Sir, where did you get the 120? Okay, you just simply multiply the 5 factorial class in descending order up to 1. So, meaning 5 times 4, 20 times 3, 60 times 2 is 120 times 1 is 120. So therefore, our final answer here is 120 possible ways. Okay? So for question number 2, okay, in question number 4 rather, we have the in how many different ways can 3 cars be parked if there are 8 available parking space? Okay, again, our n here equals 8 and our r equals 3. Meaning there are 8 available parking space and then how many ways can 3 cars park in this parking space? Okay, so following the permutation formula, once again, you need to substitute the value of L as the value of R. Okay, so this one, okay, we have 8 factorial because this is n or the value of n. And then we have the 5 factorial. Sir, you see 3 factorial here and then 5 factorial. Yes, we have 8 minus 3 is 5. So therefore, we come up 5 factorial. Okay? And then to simplify that, so since we have the 5 factorial at the denominator, we need or you need to cancel 5 factorial, okay, in order for you to easily solve, okay, the given problem. So our numbers here are 8, 7, and 6. And then when you multiply 8 times 7 times 6 equals 336. Okay, so therefore there are 336 possible ways that the 3 cars be parked if there are 8 available parking spaces. Okay, so since we are done with the permutation, so let us proceed for the new topic, which is the permutation with repetition. Okay, in other books class, they are using the distinguishable permutation. So these two words are the same. So permutation with repetition or distinguishable permutation. Okay, so let us try. Find the number of permutations of the letters of the word even. Okay, from the word even. So as you can see from the word even, there are 4 letters in the word. Suppose that these letters are distinct, okay, example, the even, then the number of permutation is 4 factorial equals 24. However, we have to take into consideration that the two is are alike, meaning the two is are the same. We cannot distinguish the difference between the two is because they are the same. Okay, so with that, we can use the fundamental counting principle. Okay, this one is a method of tree diagram. Okay, for illustration, we have the word even. We have letter E, letter B, letter E, and letter N. So even. Okay, by using a tree diagram, so these are the following word that we produce from the word even. Okay, we have word even, and then ebne, okay, EEBN, EENB, ENEB, and ENBE. Okay, for this area, okay, we have BEEN, BENE, BEEN, BENE, BNEE, then BNEE. Okay, so for the letter E, we have, okay, for the letter E, we have uh, even, EBE, EBNE, EEBN, EENB, ENEB, and so on and so forth. Okay, but if you notice, class, that there are uh, repetition. Okay, there are repetition. So the repetition are this area and then this area. So if there is a repetition, we consider that as one. So therefore, we eliminated this portion. Okay, and then proceed this, we have BEN. So let us check if there is the same. Yes, we have. So therefore, we can cancel the 1. Okay. And then we have BENE. Let us try again. So cancel it out. And then BNEE. So cancel it out. And then for the letter N, we have NEBE. Okay. Then cancel. Okay. So cancelled. Okay. So our final answer here, class, is we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So there are 12 distinct permutations. Okay. There are 12 distinct permutations from the word even. Okay. Another, when you say permutation with repetition, it is the number of permutation of n things where a things are alike, b things are alike, and c things are alike, and so on and so forth. Okay? So again, please remember this formula because along the way, you will encounter it. Okay? So our formula for permutation with repetition or distinguishable permutation, we have P equals n factorial all over a factorial times b factorial times c factorial and so on and so forth. So these three dots indicate that infinite, infinite or infinity. Okay, so let us perform this formula in order for you to easily understand what the problem all about. Okay, so find the number of permutation of the letter of the word even. So despite the fact that we are already done for this problem, but I will show you using the permutation with repetition formula. So we have P equals, since we have the 4 letters, therefore we have 4 factorial. all over, and then we have letter E and letter E. So they have repeat each other. So we have 2 factorial. So again, since we have 4 factorial, 4 times 3 times 2 times 1. So we have 2 factorial here. We need to cancel it out, the 2 factorial. So the remaining is 4 and 3. So 4 times 3 equals 12. So therefore, we have 12 distinct permutation from the word even. Okay? Another problem. Okay? So you need to find the number of distinguishable permutation of the letters in the word Mississippi. Okay? First, you need to identify what letter with repetition. Okay? From this given or from the word Mississippi, so the letter I repeat. Okay? So 4 times. And then the letter S is 4 times with repetition. And then we have 2 times P na with repetition. And then 1 M. Sir, why did you include the letter M? Because class, despite the fact that 1 M is not or without repetition, but you need to include that because we're talking about the word Mississippi. Okay? So therefore, you need to count the letters for the word Mississippi in order for you to perform the formula, okay? The formula for permutation with repetition. Okay? So 4 plus 4 is 8 plus 2, 10, so 11. So we have 11 letters from the word Mississippi. So therefore, our equation here is 11 factorial. Okay, since the letter I is 4 times, okay, so we have 4 factorial, and then we have also the 4 factorial, and then we have also the 2 factorial. Okay, sir, is it possible that uh, we simplify that 11 factorial all over 10 factorial? Okay, we cannot do that, class. No, we cannot do that. All you have to do is to perform this permutation individually. You cannot add 4 plus 4 plus 2 is 10 factorial. No, definitely, okay, is not allowed. Okay, so therefore we have 34,650 distinct permutations. So how did you get that? Okay, when you simplify 11 factorial, I think that would be 39,916,800 all over. When you do this 4 factorial times 4 factorial times 2 factorial, so meaning 4 times 3 times 2 times 1, 4 times 3 times 2 times 1, and 2 times 1. So we come up that 1,152. Okay? If we divide 39,916,800 divided by 1,152, so our final answer is 34,650. Okay? So I hope this one is clear. Okay, next. Since we are done for the permutation with formula and then done also with the permutation with repetition and then the formula. So let us proceed for the another topic, which is the circular permutation. Okay, in circular permutation class, in how many ways can 3 people A, B, and C be seated around a circular table? Okay, so there are the condition of if we have 3 persons and we want to arrange them in a line, then the total number of permutation of 3 persons taken all at a time is 3 factorial. So our answer is 6. Why? 3 times 2 is 6 times 1 is 6. Okay? So we have the following linear seating arrangement as A, B, C, okay, A, C, B, okay, B, A, C, B, C, A, C, A, B, and C, B, A. So to illustrate that, I have here the circular arrangement 1 and then the circular arrangement 2. Okay? When each person move his position by one place clockwise or counterclockwise, the position are not changed. As you can see on the circular arrangement or the illustration. Okay? So our formula for circular permutation, we have P equals n minus 1 factorial. So P equals n or quantity n minus 1 factorial. It is very easy to remember because P equals n minus 1 factorial. Okay? So here is the question. In how many ways can three people, A, B, and Z, be seated around a circular table? So we have following this formula, we have P equals, since our n here is 3, so therefore, we need to replace the value of n by 3. So 3 minus 1 factorial. So 3 minus 1 equals 2. 2 factorial. Okay, 2 times 1 is 2. Okay, so another one. In how many ways can 6 people be seated at a round table? Okay, table. Okay, here are the solution. So since we have 6 people seated at a round table, so therefore our value of n here is 6. So following this equation, so 6 minus 1 equals 5 factorial. So 5 factorial equals 120 ways. Okay, 120 ways. So therefore, there are 120 ways that 6 people be seated at a round table. Okay? Always remember this class. This is very important. Okay? The important point about the circular arrangement is as follows. Okay? There are two important uh, points to remember. Okay? The first one, if the clockwise and counterclockwise orders can be distinguished, then the total number of circular permutation of n elements taken altogether equals n minus 1 or quantity n minus 1 factorial. But in number 2, if the clockwise and counterclockwise orders cannot be distinguished, then total number of circular permutation of n elements taken all together equals quantity n minus 1 factorial divided by 2. Okay? So in order for us to visualize and understand these two conditions, so let us take this given example. Okay? In example number 1, so in how many ways can 5 different beads be arranged if the bracelet has no lock? Remember these two important points in circular arrangement, okay? We have can and cannot be distinguished, okay? So to do this, so we have P equals n minus 1 all over 2, okay? To simplify, we have 5 minus 1, so therefore 4 factorial all over 2 factorial, and then we have 3 factorial because we need or you need to cancel the 2 factorial. Okay, so the remaining numbers here are 4 times 3 equals 12. So therefore, there are 12 possible ways can be 5 different beads be arranged if the bracelet has no lock. Okay, so assuming this is the illustration class. Okay. So this is the 5 different beads. And then these two arrangements appear to be distinct. Okay, but they are mirror image of each other. Okay. One of them can be obtained by turn over the other. Turn over the other. Okay, again, since the question number 1 has no lock, in this one naman, in how many ways can 5 different beads be arranged if the bracelet has a lock? Okay, our solutions, since the bracelet has a lock, we can determine where to start. Okay, you can easily determine where to start. Unlike dun sa given number 1, you cannot. Okay, so P equals 5 factorial all over 2 factorial. So 5 factorial, if we simplify the 5 factorial, we have 120. Okay, 120. And then 2 factorial, 2. And then 120 divided by 2 is 60 ways. Okay, so in this given example also class, in how many ways can 3 girls and 3 boys sit around a circular table so that boys and girls alternate? Okay, so they have the condition here, boys and girls should be in alternate place. Okay, since this is a circular, so assuming that this position is 3 girls and 3 boys. Okay, so the condition here, si boys and girls should be in alternate position. Okay, so assuming that the seat girls around the table first, okay, we have girl 1, then of course we have the girl 2, and we have the girl 3. So alternate girl 1, girl 2, and girl 3. So how many choices do you have to sit here? Okay, they can be seated in 3 minus 1 factorial. So therefore, we have 2 ways. For the girls, 2 ways. And then for the boys, how many choices do you have to sit the boys on the 3 vacant seats? This one, we have 1, 2, and 3. Okay. To solve that, we have for the boy 1, boy 2, and boy 3. So the boys have 3 factorial or 6 ways in sitting between the girls. Okay, in sitting between the girls. Okay, so our final answer here is 12 ways of sitting alternately, 3 girls and 3 boys. 3 boys around a circular table so that they alternate from boys and girls or girls and boys. Okay, so let us try this application class. So I will give you 3 minutes to answer this application. Okay, for question number 1. So if you know the answer, you can chat it on the chat box para for you to notify. Okay, while you're answering the given task, I just want you to please like and subscribe on our YouTube and Facebook page, the Teleradyo Marcelo, ang telearalan ng bawat Maloleño. Okay, once again, I invite you to please like and subscribe on our YouTube and Facebook page, The Teleradyo Marcelo, ang telearalan ng bawat Malolenyo. Okay, from the chat box, let us notify uh, from Angel J. Elmido. She says that the final answer is 5,040. So let us check if they are up. She is correct. From Iris also, 5,040. From Haley de los Santos, okay, 5,040. Okay, very good. Ano? It almost student who participated in the chat box got the correct answer. Okay, so our our answer is 5,040 letters. Very good, Nicole. Brent Christian, Ayan Ina, Christian Vargas. Okay, thank you so much for the participation. Ano? You are very good in answering this question. Okay, another question for question number 2. I will give you 3 minutes again to do this. Your time starts now. Okay, from Gabriel Jos, Manakap, 10 Spa, thank you so much. Rene Ashley Calata, 5,040, you're correct. Okay, so I would like to use this opportunity also to say thank you to our very energetic and beautiful Principal po of Marcellus del Pilar National High School, Ma'am Bibo, thank you so much po. And of course, to our department head, Dr. Marco Ronel Eusebio. Sir, thank you sa support and guidance. And of course, to my two ladies, the master teachers of grade 10, okay, Ma'am Cristina Laderas and Ma'am Penny Serapia. Thank you so much for this PowerPoint presentation as well as the script. And of course, doon po sa kasama ko sa Math Department. Okay? Thank you so much, guys. Maraming salamat sa support. Okay? Thank you. Okay, so from the chat box, so napakadaming sumasagot. We have Marian de la Cruz. Marian de la Cruz, 6,306,300. So let us check if they are correct. Okay, very good. Our answer here is 6,306,300 ways. Very good, Marian de la Cruz. Lexin Jos Diano. Hartzell. Okay, Carl Santos, you are very good because you got the correct answer, 6,300 or 6,306,300. And then Angel J. Elmido, you got the correct answer also. 6,306,300 ways, as well as Maki Lopez, Brent Christian. Okay, so let us check again for question number 3. Find the number of ways in which 7 people. Okay. So thank you so much for the following sections. Section 17, Beijing, SPFL. Section 13, Section 19, as well as the SPS, Section SPS. And of course, for those students who participate in this session, thank you so much, guys, for your time. And I hope that you learn, for this session. Okay. So this is the condition. Standing next to each other is considered as a single entity. So N equals 5. Joseph, Richard, Jenny, Christy, Penny, Cherry, and Ninette. Okay, so we consider this one as 5. So Richard, Joseph, and Jenny has their own arrangement, and that is 3 factorial. Okay, so let us check the answer of the following students. There are 720 ways from Hartzell, 720 ways from Luke, Nicolai, Fernando, 720 ways. Very good. Okay, so there are 720 ways. Actually, nakakatuwa yung mga estudyante na they are happy in participating this session. Ay nakakatuwa lang talaga. Thank you so much talaga dito sa ganitong opportunity dahil kahit papaano natututo yung mga estudyante. Okay, so let us proceed. Okay, another question. Find the number of ways. Okay. So the condition is sitting next to each other is considered as a single entity. So Joseph and Jenny has their own arrangement, and that is 2 factorial. So therefore, okay, for this question from Balatbat, okay, si Balatbat, he is the first to answer. We have 240. Okay, very good. The answer is 240. Okay, so actually, when I see the chat box or the comments of the students, okay, they are all the same answer, 240 ways. Okay, Sophia Zabel Kiambao, 240 ways. From Lexin Joyce Diano, 240 ways. Very active si Lexin. And then we have from Margaret Limbo, 240 ways. Okay, very good. From Iris Abigail Gloriosa, 240 ways. Okay, so our answer is 240 ways. Okay, with that, thank you so much, guys, for your participation. Thank you so much and keep safe. Once again, I would like to read this encouragement. Okay, please like and subscribe on our YouTube and Facebook page, Teleradyo Marcelo, ang telearalan ng bawat Maluleño. Okay, once again, this is your mathematics teacher, Mr. Richard R. Martinez, signing off. Bye-bye.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo.